Well, welcome back, AP Statistics students. Happy Friday, August 21st. Yay, statistics. We actually get to do some statistics today. We'll be learning about individuals, variables, and deceptive graphs. So let's get started. So my learning intentions. You'll hopefully at the end of the video you'll know how to identify individuals, know the difference between categorical and quantitative variables, know the difference between a sample and a population, and explain why a graph is misleading. At the very end of the presentation I have quite a few misleading graphs that I find fascinating. So number one, part A. Who are the individuals in this data set? This is data that I collected on 10 Classical Academy High School faculty and staff. I asked a bunch of staff, and then I randomly selected 10 of those who responded. From pretty much the whole school responded. But this is a data table or data table. Data or data, I've heard them both ways. So I go back and forth with those. But we have different variables represented here. The individuals, though, would be 10 Classical Academy faculty and staff. So individuals probably is what you would think it means, like who are the individuals represented. But I do want to point out that dogs are individuals too. Sometimes when we think of individuals, we think of just people. But individuals could be cars, could be trees, anything that you're collecting data on. So if you're collecting data on dogs, like Ebbie, there's my Ebbie, dogs can be individuals too. Part B, what variables are measured? Identify each as categorical or quantitative. And again, probably based on the words, quantitative as in quantities and categorical as in categories. So if someone's asked a question and they give a numerical answer, like number of siblings, 0, 1, or 2, or 3, or 4, 5, 6, AP classes that they took while they were in high school, one of these teachers had a female teacher had 7 AP classes in high school. Impressive. And then this column over here, morning commute, 30-minute commute, 80-minute commute. All those are quantities, things that we could measure, things that we could put in order from like ascending to descending or descending to ascending. There are things with units, like morning commute, 30 minutes, 3 classes. This one over here, yes. Yes doesn't really have units. Yes units or something. A book. Book doesn't have units. But morning commute, 30 minutes has units. Or one sibling units. Those things have units. Also, you can think of a quantitative variable as something that you could average. It makes sense to average number of siblings. It makes sense to average the number of AP classes while in high school. It doesn't make sense to average yes. Like you can't really have a 7.5 yes average or something. It doesn't make sense to average. They're not numbers. You can't average them. So that leads us to categorical variables, things that are categories or words, and it doesn't make sense to order them. You can't really order yes and no. Like you put yes first, you could put no first. There's no inherent order. It's not like a number line that you order them. And then male, female doesn't make sense to like average those. You can't order them. I do want to mention area code. Maybe you thought area code, since it's a number, should be a quantitative variable. But area code is really representing a geographical region. So it doesn't make sense to like average area codes. It doesn't make sense to like put them in order and find the median area code. You would just count how many area codes are 619 area codes. And there are 3 out of 10 that are 619 area codes. So even though area code is a number, it's really a number that represents a category. And the last one I want to mention is this one, the identification number, the ID. An ID or a person's name is not a variable at all. This is a number that I assign to them. This isn't like all this other information are questions that I could ask a person. An ID is a number that just helps me organize the data. It's not really a variable that we're measuring. So an ID or the person's name, maybe if this first one was like Mr. Montgomery or something, Mr. Montgomery is a name, but it's not a categorical variable because it's just his name. It's not something that we measure. How many Derek Montgomerys are out there? So those are types of variables. Describe the individual in the first row. So the individual in the first row, with data like this, a row is an individual and a column is a variable. Other than this ID, column is not a variable. But columns are typically variables in spreadsheets like this, or tables, and then rows are individuals. So the individual in the first row, we'd say, is a male with no siblings who took 3 AP classes while he was in high school. He has a cell phone with the internet. He likes to read a book over watching TV. He has a 30-minute commute on average, and he has a 760 area code. D. So this is AP statistics. What exactly is or are statistics? Students often ask that. Sometimes that's like the first question that I'll hear that students have is like, what exactly is this class that I'm taking, statistics? So let me show you some statistics. This is a sample of 10 faculty and staff. So we could find a statistic. A statistic is something, a characteristic from a sample. So we could count, there's 7 females here. So we'd say 70% of the sample is or was female. That's a statistic. We could say 100% of the sample have cell phones. That's a statistic. 30%, 1, 2, 3 out of 10, 30% have an area code of 619. That's a statistic. Those are our categorical variables. Categorical variables, we use percentages to summarize as statistics. Whereas for quantitative variables, we use an average, for instance. We could use that. There's a bunch of different statistics we could use with quantitative variables, but if we average all these AP classes while in high school, that would be, on average in this sample, 3.2 AP classes while they were in high school was the average number of AP classes for this sample, and that's a statistic. So we have percentages could be statistics for categorical variables. An average could be a statistic for a quantitative variable. The median commute, if we find the median of these numbers, the median commute is 30 minutes, and that would be a statistic. The median is a statistic. Letter E, 10 out of 10, 100% of our sample have smartphones, phones with the internet. Does this mean that the population of all Classical Academy faculty and staff have smartphones? So one of my learning intentions today is that you can tell the difference between a sample, this is a sample of 10, from a population of about 30 Classical Academy faculty. So a sample is just a smaller part of a population. So do we know that the population of all faculty and staff have smartphones? Well, we would say no. Although the entire sample has smartphones, we can't be fully confident that the entire population will too, that the entire population would have smartphones. Now you might think, like, everybody has smartphones. Can't we be pretty confident about that? Well, it looks like if we have 100% of this sample and it was a random sample, we could probably be pretty confident that a very high percentage of faculty and staff would have smartphones. But we can't know for certain that 100% do unless we go around and ask them. And obviously that's what I did. Let me show you the distribution of owning a cell phone that has internet access. So this was a sample. Our total population, I guess, had 50 faculty and staff. And you do notice that there was at least 1 or 2 that did not have, that has cell phone without internet access. So again, we would be kind of surprised if these were like flip-flopped. Our sample had 100% have internet access on their phones, and you would think most people do. But there are a couple people that don't have internet access on their cell phone. But this is a distribution of a variable, and it tells us the values the variable takes. So these values are yes and no, and how often it takes these values. The yes occurs a lot, the no doesn't occur very much. Here's a different distribution of a variable. The values that this variable takes is TV or book. And how often it takes those values, it looks like book wins, maybe because they're teachers and they feel obligated to look educated or something, that they said book. But about 31 said book, and about 18 or so said TV. Those are categorical variables. So we use bar graphs like this to show categorical variables. And we use other types of graphs like this one to show quantitative variables. So this is a distribution of the number of AP classes taken while in high school. The values the variable takes are 0 to 7, and how often it takes these values looks like a majority, like quite a few faculty and staff and teachers didn't have any AP classes while they're in high school, and I find that fascinating. And quite a few people had just one AP class where they're in high school. But then we have the overachievers who had 7 AP classes. That's really impressive. 7 AP classes while they're in high school. Later in this chapter, we'll talk about how to talk about this type of distribution. Since we're here and I just can't resist, we would call this a right skewed, because we have this long tail on the right, the majority are on the left. So a right skewed distribution, but we'll talk more about that later. But those are distributions. Basically throughout this course, pretty much in every chapter, we'll talk about different types of distribution. So it's important for you to understand that a distribution tells us the values the variable takes and how often it takes those values. We're not done just yet, but at that point, you could pause this video, and if you wanted to jump into some Khan Academy work, what should you do later today? On Khan Academy, find the following in your queue. Identifying variables. This one right here is a video. It's 2 minutes long. This one, individuals, variables, categorical, and quantitative data. That's an exercise. That's 4 questions. I'd encourage you to at least get 3 out of 4 if you can't get 4 out of 4. And then creating a bar graph, that's a 1 minute. And then reading bar graphs comparing 2 sets of data. That's also a video, and just a 1 minute video. You'll notice here, do not search for the assignment ever. I've said it once and I'll say it again. It's really common at the beginning of the year for students to go on Khan Academy and like type this title in. You definitely should not be doing that. If you do that, you might not get credit. Since you're in my course, you have to kind of go through my course when you do these assignments. So how do you join my course? I'll make myself appear again. Hi, I'm back. Did you join my Khan Academy course? Yesterday, Thursday's homework, you had to do an AP syllabus, read the syllabus and answer that quiz. Post a discussion post just so I know that you are knowing what you're doing. You can read that and post that. But right here, join the Khan Academy course. If you click on that right there, that'll show you the link that you can use. I also included it here. It's basically a 1-question quiz. Follow this link, click on that. It'll take you to the, that's the course code at the end, but you click on that. I recommend using your TCA Docs account when you sign up. If you already have an account and it's not TCA Docs, then that's okay. But make sure when you pick your username that I can tell who you are. Don't pick something mysterious like iHeartStats25, even though like that would be really amazing. But I need to know who you are so I can give you credit as you're doing your Khan Academy work. And again, make sure you're getting credit. If you're going to do this on your phone, at least the last time I checked, it looks like this. When you're in the Khan Academy course, there'll be 3 bars at the top right. Click on that, scroll down and select notifications. And then it should say somewhere you have blank new assignments, and that will take you to the assignments page. And then scroll down and select start. If you're on a computer or a Chromebook, you'll be logged into Khan Academy. You'll select your learner home in the top right. Look for assignments in the left margin, and then click Start Assignment. Again, never search for the title of the assignment. It looks kind of like this. That Start Assignment is this blue button right here. So the first one you could start is this one, and then the first exercise is this. But these other 3 are quick videos, and then that middle one right there is the exercise. So make sure you're doing it right. When you enter the AP Stats Khan Academy, you will have, you'll be offered to take a course challenge. I'd encourage you to do that. It's 30 questions. It should take like 30 to 45 minutes. I think most of them are multiple choice. But here's the thing about the course challenge. The course challenge is basically like if today were the AP exam, how would you do? Now, I'm not expecting that you do very well, and you shouldn't have that expectation on yourself either because you haven't actually taken the AP course. but you will learn all this stuff, and by the end of the course, you should be way more confident and competent to answer these questions. So the course challenge is just a way to kind of measure like where you are to start. And it's really okay if you don't do very well on that course challenge. So that's why I have tears of joy. There might be tears in the evening, but joy will cometh in the morning, or something that they say. So you could take that course challenge, and but again, don't feel bad if you don't know the terminology and the vocabulary, because really nobody does. Not yet, at least, but you will. Next week, since we're here, I'll talk about next week. The Welcome to AP Stats General Information folder at the very top. Just want to point out again where the live instruction bell schedule is, so you can click on that link. And then the link right below it is the Zoom link for the live class times. So if you have any questions, again, here's my email, or you could Schoology message me. I'd love to hear from you, especially since I won't often get to see you face to face. It's nice to hear from you. But then the last part of this video, we'll talk about some deceptive graphs. So deceptive graphs, probably maybe one of the most relevant things that I'd like you to be cognizant about is how to read graphs and know if they're deceptive or not. So let me give you an example. What's deceptive about this graph? This is an advertisement that I've seen. DirecTV stomps the competition. DirecTV offers 95 of your favorite HD channels. Dish Network offers 81, and cable offers 56. Now I've done a little math here. 81 plus 56 is 137, kind of like total channels between the two. So what's deceptive about this? Well, if you take this Dish Network and this cable and you overlay it on this area right here, this area now, which is like representing 137 channels, is like disproportionate. It should be 95 channels, but the sizes of the boxes are really deceptive. It makes it look like, because of the bigger font, the nicer color, obviously DirecTV has something they're trying to convey here, but the heights and the areas aren't really proportional, comparing this 56, this 81, and this 95. I'll show you another example similar to this that happened in our very own Classical Academy Crimson newspaper. And this was back in 2015. It was on page 7 if you want to check my work. But this says, according to the FBI reports in 2010, there were this many gun deaths per state for states with gun ownership. And there were, let me restate that. According to this. According to the FBI reports in 2010, there were this many, 200 and some, there were this many gun deaths per state for states with gun ownership less than 50%. So not a lot of gun ownership. And then this one, that's states with gun ownership larger than 50%. And they only recorded about 55 average deaths per year. So it would seem that this is trying to convey that if there's gun ownership in a state, then there are fewer gun deaths. If there's less gun ownership in a state, then there's more gun deaths. Now, there's a lot more that we could say about this, but what I want to focus on is how the areas make it a deceptive graph. So if we compare the numbers, this 54.8 versus this 232.6, which I think might be a typo here. These numbers differ, so I'm not sure which one is the correct one. But we'll just go with the one on the graph, 232.6. This one should be about 4 times higher than this one. And it might be a little higher than 4 times higher. But notice if we took this area and we put it inside this bigger area, we would get it's 7 times bigger. So one of these, and there's 7 of those. So really, because of this area that's being used, it makes it look like it's 7 times bigger, not just 4 times bigger. This graph is 7 times bigger. So that's a little deceptive. Anytime you change the width and the height, you're going to have a deceptive graph. And there's other ways that deceptive graphs happen. One of the, another really common, I guess there we go, I'm back. One of the most common ways, if you look at this one on the left, this group A looks much, much higher than these two. But that's because they started the axis at 50. So they basically cut off the bottom 50% with whatever these groups were doing. But this accurate graph starting at 0, you can see it's not as stark of a difference between group A and group B and C. So this is a deceptive graph. And this is really common for people to use to really like emphasize their point or something, to cut off the bottom part of the graph. And I have several examples of this happening in the actual media. That's, a big gap compared to that's much smaller. This was from a long time ago, 2013, I guess. Well, it was probably 2013 is when the Bush tax cuts started, and they were concerned. But anyway, so just what I want to point out on this graph is the scale is incorrect. It makes it look like there's this huge difference, but really this is 35%, and that's 39.6%. So really that's a 4% difference. And that might be really significant for a tax rate because, if you're a millionaire or billionaire, 4% difference is a lot of money. But just visually, it makes the graph seem much more of a stark difference than it really should be. So that's another misleading graph. This one, KFC's crispy chicken twister. You'll notice again at the bottom here, they start the graph at 590 calories. So it makes it look like Wendy's, Burger King, and Taco Bell are way, way bigger than like McDonald's and whatever the green pizza place is at the top. But these differences really aren't that stark if you would actually start at 0 calories instead of 590 calories. So that's another example of that same issue. And this one, ESPN Football Power Index projected win totals. This is just a confusing graph. Like, I'm not sure why 10.9 would be a shorter bar than 8.4. So that's something just to be cognizant about. Like, sometimes graphs are just confusing. I'm not sure what they're trying to state here. Maybe this was made by a Mississippi State fan or a South Carolina fan to say, hey, our teams are better. Even though we're projected to win less, our team is better. Another example is with scatter plots. The one on the left is misleading. It doesn't look like much of a change or growth in this positive upward trend. So you can tell the axis, they have a lot of extra space on the top, but if you zoom in a little bit from 0 to 15 instead of 0 to 40, you can see a lot more of the contours of the graph. And just as an example of that, you might look at this, and if I told you, hey, here's what the Dow Jones Industrial Average, the stock market, is doing lately, you'd think, oh man, that's kind of a decrease there. That's kind of a problem. It's going downhill. But that's just one day. Notice the scale here. There's really not that big of a difference here. Whereas if you look at the year to date, right around here is when the COVID lockdown started. So actually the stock market is on the up and up. So it's actually trending more positive. Now, if you look at individual days, you're going to have a lot of change in individual days. But overall, it looks like the stock market is improving. We're not yet back to the pre-COVID time, but we're actually pretty close, according to this 1 year. Another common mistake that people make, maybe just making pie charts is a mistake. Pie charts are kind of hard to make without technology, so we don't do much with pie charts like the one on the left. But I hope you notice about this pie chart. Can you tell why this would be misleading? Like, I don't know what 38 plus 50 plus 64 equals, but it should equal 100% for a pie chart. So a much better appropriate way to display this data would be in a bar graph, that 50% prefer team A, 64% prefer team B, 38% prefer team C. Maybe people can choose multiple at one time. Whereas with a bar chart, it should add up to 100%. And you might be skeptical, like, would this really happen? Well, yeah, it can happen. The biggest COVID-19 worries. This pie chart, 62 plus 48 plus 68, that's more than 100%. So this error is just picking the wrong type of graph to display the data that you're trying to display. Another COVID mistake in this graph. Notice the scale goes from 0 to 5 and then counts by 15 after that. I'm not sure why they chose to do that, but more appropriate, counting by the same, like having your scale be accurate. This is counting by tens each time. You can see the growth. It's much different than this slower growing number of cases. And that was back in mid-March. So that's kind of an issue of using the wrong scale. I'll get rid of my picture here so you can see it a little better. And only a couple more graphs. This one's misleading. The one on the left is misleading. This is individuals per kilometer. It's more common, I think, and just visually. Usually darker colors indicate more density, but they've switched the colors. So a lighter color is less density and a darker color is more dense. So like if you just glance at this, you're like, oh man, California, Arizona, Colorado, those are all like very dense. But actually, if you did it correctly, where lighter colors are less dense individuals per kilometer, I'm not sure what they're measuring. But this gives a different perspective, right? Now it's like, oh, okay, this is density, you know, Washington, Texas, Virginia, West Virginia. Those are problem areas or whatever this is talking about. Compared to, you'd have the opposite perception in this graph. I think I just have one or two more graphs. Here's a deceptive COVID graph again. This was back in May. This is counties in Georgia. I believe it was Georgia. Counties with the greatest number of COVID cases. If you just glance at this graph, you would say like, oh, hey, we're on a downward trend. The number of COVID cases is decreasing over time. And that would be great. But sadly, if you look a little bit more closely at the axis, you see that the dates are all mixed up, and that's kind of a problem. And also by grouping all the counties together, it's harder to tell. Like this blue county on the left is now suddenly on the right, and then it's on the right, and it's decreasing in the blue. But then the days are mixed up, so it's really hard to tell like what are the number of cases, what's actually happening with the number of cases in these counties. And that's just a kind of a funny graph. You could pause and you could try to figure out what's going on there. This is the most used word in each state based on something search data. But you could try to figure out what they're trying to convey there. But thank you for watching this video. Again, your assignments are some Khan Academy assignments. That'll be pretty common homework for you. And then make sure you check Schoology for any Monday assignments. And then I will see you Tuesday for our first live session. I'm looking forward to it. Thanks again for watching this video, and feel free to message me or email me if you have any questions. Have a great day.